So in this one, I'm just going to be working through some of the practice problems from the second practice sheet, the one that talks about angles and functions. Here we go. First off, reference angles. So in each case, I want to make sure you know where the reference angle is. It's always between your terminal side and the nearest x-axis. So in this first case, there's my reference angle. Now, how big is it? Well, I've got 560, so that's a full rotation. So I'm just going to say, all right, I got 560. Take away 360 for that first full rotation. Then take away another 180 for this half rotation, and that'll leave me with just this leftover part. And so when I do that, 560 minus 360 minus 180, that means my reference angle is 20 degrees. I don't know, looks about right. Now for this one, again, make sure we know what we're talking about. It's always between your terminal side of the nearest x-axis. That's the angle. So I'm going in the negative direction, 685. That's one full turn. So I'm going to take my 685 minus a 360. It's then another half a turn, minus 180. It's then, actually, you know what? I'm going to rework how I'm doing this. Rather than doing that, why don't I recognize, hey, this is almost 2 full turns. Yeah, that's a much better strategy. Because it's almost 2 full turns, I'm just missing a little bit. So 2 full turns, that would be 720 degrees. Take away the 685 I've already gone. 720 minus 685 means I'm missing the final 35. Oh, that's much more efficient. So reference angle this time, 35 degrees. Okay, next up. On this one. Now, I'm going to use the same strategy we used this last time, because notice, the reference angle here is a part that I don't have. That's going to make this strategy the more efficient one. Whereas on this first one, we had a little extra, so that's the more efficient strategy. Here, I'm missing something. So let's think. This is almost 1.5 full rotations. Well, 1.5 full rotations would be 3 pi's. Take away the 11 pi over 4 we've already gone. So on my calculator, I'm just going to do this. I'm going to take 3 minus 11 over 4. Now notice, I'm leaving the pi's off. There's a reason for that. If I do this, I can now go into my math menu, turn it into a fraction, and say, all right, that means I'm missing 1/4 pi, which is going to be pi over 4 for the reference angle. Now, if you put the pi's in, it's going to make your decimals big, long, and crazy, and then your calculator doesn't know how to turn it back into a fraction. So I just leave the pi's out, and then when I'm finished, I remember, okay, multiply this by pi when you're done to get that reference angle. And here, once again, we're missing a little bit, so I'm going to use this same strategy. It's almost a full rotation. How much is missing? Well, I've gone 11 pi over 6. How much is left? Back to my calculator. I'm going to take 2 pi minus 11 pi divided by 6. Turn that into a fraction. That means I'm missing the final pi over 6. So there's your reference angle, pi over 6. Your reference angles should always be positive, 100% of the time, and they should always be between 0 and 90 degrees, or 0 and pi over 2 radian. Next up, we didn't do any like this in the lesson, so let's just talk about it now. Are these coterminal, meaning do they end at the same spot? There are lots of strategies you can use to figure this out. I think I am just going to figure out where they are and see if they're in the same place. So for example, 43 pi over 36. So I'll do this one in red. That's going to be 36 pi over 36 is a half turn. And then 43, what's 43 minus 36? That should be 7, right? Yeah. So that means my leftover bit, my reference, this extra part right here, is 7 pi over 36. So this red angle ends up being in quadrant 3 with a reference of 7 pi over 36. Is this the same? Well, it's negative, so it's going in this direction. The question is, if I take this and if I go another 7 pi over 30, oh no, I take that back. Forget that part. Let's figure out what the reference angle is for this one. So I'm going to say, all right, 29 pi over 36. That doesn't quite get me to a half rotation. So the question is, how close does it get me? Well, a half rotation would be 1 pi. I've got 29 over 36. That leaves me with a reference of 7 over 36. Look at that. So this one goes this direction and ends up there. The other one went the other direction and ended up there. Yes, these are coterminal because they end up in the same spot. They will have the same sine and the same cosine because they are at the same location in the unit circle. Let's go again. Here and here. So 10 pi over 9. This one I can kind of just do in my head. 9 pi over 9 is half a rotation. So I've got to go an extra 1 pi over 9. It's going to be in quadrant 3 with a reference of pi over 9. 28 pi over 9. Okay, so let's see. That's going to be halfway around is 9. A full way is then 18. Another half would be 27. And then another 1. So this one goes 9, 18, 27 pi over 9s. I need one more for 28 pi over 9. Sure enough, once again, ends up in the same spot. 320 and 20. So in degrees, 320 is not quite all the way around. It's going to put me down here with a reference of 40 degrees. Well, in 20, well, that's just this. That's 20 degrees. These are nowhere close to being the same thing. So no, those are not coterminal. And then lastly, 240 and 600. So 240, that's going to be 180 degrees plus another 60. So it's a 60 degree reference down here in quadrant 3. Now 600, that's going to be a full 360. And then what is 600 minus 360? Oh, 240. Okay, so the 600 is all the way around and then back to where we started here, the same thing. So yes, these are coterminal because they end up in the same spot. Hey, if all you have to do is check if they're coterminal, and if you have a calculator available, just check and see. You got to check both of them, but are the sines of the angles the same? And are the cosines of the angle the same? So for example, on this first one, so I'm in radian. If I do the sine of, what was the angle? 43 pi over 36. Gives me that number. Let's check now the other one, sine of negative 29 pi over 36. Okay, get the same number. That's not enough though. You've got to check the cosines as well. So second enter, second enter. Now let's check the cosines. Second enter, second enter. Check the cosines. If and only if. So the sines match, do the cosines also match? Yes, they do. Well, then that's another way to check and see if they're coterminal. I actually like that. Next up. This happens a lot, and especially those of you heading into pre-calculus, you're going to be expected to be able to do this relatively quickly. So we've got here an angle of negative 190 degrees. Well, that's this. So it's negative 180 plus another negative 10 puts us right there. Reference of 10 degrees in quadrant 2. Here's the thing, though. It's coterminal with this blue angle. This blue angle is between 0 and 360. It's a positive angle that's less than one full rotation. This is asking, what angle is that blue angle that gets us to the same spot? Well, it's a half turn minus 10 degrees. So that's 170 degrees. Let's go again here with negative 225. So that's going to be a half turn back and then another 45 degrees. So that's a 45-degree reference in quadrant 2. Question is, okay, well, how much is this blue angle that gets us to that same spot? So in the positive direction, less than 1 full turn. Well, that's going to be 180 minus 45, which is 135 degrees. In radian, same thing, except we're now counting by pi's and stuff. So 35 pi over 12, that's, let's see, 12, 24, 36 pi over 12 would be 1.5 turns. So it's 12, 24, 35. So it's this angle with a pi over 12 reference in quadrant 2. Well, how much then is this blue angle? That's positive, less than 1 full rotation that ends you up in the same spot. Well, that's going to be a full half rotation minus this pi over 12 reference, which should then be 11 pi over 12. And last one here, 31 pi over 9. So here's 9, 18, 27. Okay, that leaves just 4 more. Now, because 4 is less than half of 9, I know it's going to be over here somewhere. So a 4 pi over 9 reference in quadrant 3. Well, what blue angle in the positive direction, less than 1 full turn, gets us to that same spot? Well, that's going to be a pi plus this reference of 4 pi over 9. Common denominator gets us to an angle of 13 pi over 9. Now, the way I've shown you is not the only way to do it. If you come up with a way you like better that always works, more power to you. This last set, this is just making sure you can use your calculator okay. Now, if you're using the handheld calculator, I'm going to show you how I keep my radian and degrees straight. And that is, I just keep my calculator in radian all the time. And when I want an angle, I put in the angle symbol. Here's what I mean. For the first one, I want cosine of negative 739 degrees. So cosine of negative 739 degrees. Now, if I press enter now, it's going to do the cosine of negative 739 radian. To make it degrees, do you see above your apps button, it says angle? If you press second apps, there's a degree symbol that you can put in. And that's how I do degrees. So I keep my calculator set in radian all the time. And then when I want degrees, I just put in that degree symbol. So this cosine is 0.9455. So 0.9455. There you go. Now let's make sure that's reasonable. So I know, for example, that in quadrant 4 here, cosine is x's. The x is positive, so this should be a positive number. Okay, I'm going to buy that. For now, tangent of 1028, coming back here, tangent of 1028. I got to remember to put the degree symbol on, so second apps 1. Ends up being negative 1.2799. Now, we didn't talk about tangent, but just know tangent's a little bit different. Its values can go above 1 and below negative 1. And when you're keeping track of the positives and negatives, think about how tangent is figured. It's opposite over adjacent. And in this quadrant here, the opposite is a negative number. The adjacent is a positive number. So when you divide them, you should get something negative. So yeah, this perhaps seems reasonable. I'm going to trust my calculator. Now here, cosine 8 pi over 3. Cosine 8 pi over 3. Now, because my calculator is already in radian, I don't have to do anything. That ends up being negative a half. Let's make sure that seems reasonable. Cosine is x's. And over here, the x is a negative number. Yeah, I accept that as being true. And then lastly, tangent negative 3 pi over 4. So tangent negative 3 pi over 4. Ooh, ends up being 1. Let's just make sure that seems reasonable. Again, checking the positives and negatives. The opposite side is down, so that's negative. The adjacent side is left, so that's negative. Negative divided by negative is positive. I'm going to accept that as being true.